in today's video I have brought you a very nice problem. Here is the following statement: find all natural numbers n and x satisfy this equation. So we have this equation, we have a combination between x variable and the power of 2 in terms of n, okay? As x is increasing up, that means the power of 2 is growing as well in terms of n. It's very clear here. So in order to solve this equation, we are going to make the factorization on the left hand side of this equation to see what's the right hand side of this equation looks like, okay? So you guys, you can give that try to this problem pre-regret the solution. Go ahead, pause this video anywhere, you come back to see the full solution, okay? Now let's jump into the solution. So we have this following equation. So the number of the terms is 4. Now the first thing that I'm trying to do now, I'm going to split this 5x squared and 7x. So I will have x cubed. I'm going to split the terms in order to get the common factor. So this minus 5x squared becomes minus 3x squared minus 2 times x squared. Then I'm going to split also 7x into two terms. I get here x plus 6x minus number 4. I'm going to split number 4 by two terms. I will have minus 2 minus 2. This minus 2 which left here, I'm going to move it over to the right side of this equation. It becomes plus 2, which means I have 2 to the n plus number 1 as a power plus number 2, okay? Now here is a nice thing here. So I'm going to pick up x cubed with this minus 2x squared. I'm going to rearrange and group two terms. I get x cubed with this minus 2x squared as a first term, like this. Then I'm seeking for the second term. In the second term, I'm going to pick up this minus 3x squared with this 6x. I get here minus 3x squared plus 6x. Then I'm going to check x minus 2. Lastly, I get x minus 2 equals 2 to the n plus number 1 plus number 2, like this, okay? Then I'm going to take x squared as a common factor for the first term. So I get here x squared is multiplied by x minus 2, like this, okay? For the second term, I'm going to take minus 3x as a common factor. Becomes x minus number 2 here. Then x minus 2 equals 2 to the... Then I'm going to take number 2 as a power. I'm going to take number 2 as a multiplier. Is multiplied by 2 to the n plus number 1, like this. Then I get x minus 2 as a common factor for each term. So now it will be factorized as x minus 2 factor x squared as a first term. The second term, it will be multiplied by minus 3x. The last term, it will be multiplied by number 1. So the entire thing, it will have 2 is multiplied by 2. It will have 2 is multiplied by 2 to the n plus number 1, like this. Now I have ended with this nice expression here. We are going to check the parity of x. If you go back to the original equation, so we know the right hand side of this equation is a power of 2 and even, okay? So which means the left hand side of this equation is also even, okay? So we know that this one is even, so which means this part must be even, okay? In order to prove this one is even, let's do it in the opposite way, okay? Let's assume this part is a odd. If this one is a odd, which means x is a odd, but odd minus even becomes odd. Odd equals even, which is impossible, which means x is not odd, x is a even, okay? X must be even. Since the right hand side of this equation is even, which means the left hand side of this equation must be even, okay? We are going to make the comparison between this one and this one. Since we know x is a even, which means x minus 2 is a even. This one is a odd, because even minus even is given as even, plus 1 becomes odd. This part is a odd, this one is a even, okay? Let's write it down. This is odd, but this one is a even, okay? here is a problem. Since this one is an even, this one is an even, this one is an odd, this one is an odd, we almost say x minus 2 equals to 2. But unfortunately we cannot say that, because if this x minus 2 contain the odd factor, this odd factor is going to join this odd part here. Then the value of this one is going to be changed to the new value where we will have a problem, okay? Because this value then becomes a new value which we don't know about it. If we believe x minus 2 is going to be number 2, we are going to prove it cannot have odd factor, okay? So before I proceed with that, so I'm going notice here, notice number 4 cannot divide x minus 2. This is the first thing we should know, because the large power here of the evenness is number 2. It cannot exceed number 2 here, okay, because this part is odd. But it can be multiplied by the odd factor. For example, if we have like x minus 2 equals 6, which means 2 is multiplied by 3, we will have odd factor as a number 3 here, okay? So and so on and so on. We can, so by the way of contradiction, suppose x minus 2 equals number 2 is multiplied by odd prime, like this, okay? This is odd prime. You can call it odd factor, but we call it odd prime because if you have the factorization prime, if you have, like, for example, if you have like 15, 3 is multiplied by 5. So 3 is a prime and 5 is a prime. So we will have the factorization prime here. I'm simply going to insert this value into this equation to see what's given. I will have x minus 2 will be replaced with 2p. So x minus 2 equals 2p, which means x equals 2 is multiplied by p plus number 1, like this. I'm going to take this value of x and insert it into this equation. I get 2p is multiplied by 4 p plus number 1 quantity square minus 3 is multiplied by p plus number 1 plus number 1. I get 2 is multiplied by 2 to the n plus number 1. So this number 2 will be cancelled out. So by simplifying this expression, get here 4p square plus 2p minus number 1 equals 2 to the n plus number 1, like this, okay? If we try to factor this expression, we cannot factorize this one because this one is not containing any integer roots, but it has a real roots. So we are going to leave it like this, okay? But we have the product here, p is multiplied by this one. If you go to the right hand side of this equation, then if n is even, what does it mean? Since we have a plus sign here, this one becomes non-factorable polynomial. We cannot factor out this polynomial. But the left hand side of this equation is already factorized, okay, in two terms, because we have two terms in this product. We have p is multiplied by this one, which means we are seeking for the big number. You can take this big number. The small number is going to take this small number. The small number is number 1, which means p is going to take number 1, and this expression is going to take 2 to the n plus number 1. So let's check if n is odd. If n is odd, this polynomial is going to factorize on the form of the product. This one becomes 2 plus number 1 factor 2 to the n minus 1 plus 2 to the n minus 2, and all the way down to the number 1, like this, okay? Because n is odd, okay? 2 plus 1 is 3. But this 3, now we are going to make the comparison between term by term, okay? Which means p is going to take number 3 as a small number. Other stuff is going to be this one. So in this case, p must be equals 3, okay? We can prove it in the other way as well, okay? So we know, so if n is odd, so we know p divides 2 to the n plus number 1, okay? It is according to the divisibility statement. 2 to the n plus number 1 is congruent to 0 mod p. Well, on the other hand, we know 2 to the n plus number 1. I'm going to reduce this one to mod 3. if I'm going to reduce this to mat 3, I'll get here 3 minus 1 to the n plus number 1. This 3 becomes 0. I will have minus 1 to the n plus number 1. As we said, n is odd. This minus 1 to the n turns into number minus 1. Is a congruent to minus 1 plus 1, which is a congruent to 0 mod 3. If this one is a congruent to 0 mod 3 and the above one is a congruent to 0 mod p, which means p equals 3, both statements indicate p must equals 3. Okay, now since we found p equals 3, which means this term x minus 2 has an odd factor, which is 3. So I'm simply going to use this value of p and insert it in this setup to find x. So I will have x equals 2 is multiplied by p, which is 3, plus number 1, which is 4, which is 8. If x equals 8, so I'm going to use this value of x into the original equation to see what's given us. So I will have here x minus 2 is going to be replaced with number 6 is multiplied x squared. I will have here 8 squared, which is 64. I will have here 3 is multiplied by 8, which is minus 24, plus number 1 equals 2 is multiplied by 2 to the n plus number 1. Okay, then I'm going to cancel out number 2 here, then this one becomes 3. Then this chunk becomes 64 minus 2, this bit 64 minus 24, which is 40 plus number 1, which is 41. Okay, so I will have 3 is multiplied by 41, which is 123, equals 2 to the n plus number 1. By taking this number 1 to the left, I get here 122 equals 2 to the n. This 122, which equals 2 to the 7, which is 128 minus 6. But this one is not a power of 2, which is impossible. It's clearly a contradiction. Now up to here we found a contradiction, which means this setup, which means this assumption that we have chosen before is not going to work, which means this x minus 2 doesn't have odd factor. Okay, which means this x minus 2 going directly to this number 2 is going to take number 2. Finally, thus x minus 2 is going to be number 2, and x squared minus 3x plus number 1 is going to be 2 to the n plus number 1, like this. Okay, so plug in this one into this one. So here I get x equals 4 because 2 plus 2. Then using this number x, using this value of x and insert it into this one, I will have here, I will have 16 because 4 squared. I get here 3 is multiplied by 4, which is 12, minus 12 plus number 1. This one is going to give us 16 minus 2, which is 4, 4 plus 1, which is 5. 5 equals 2 to the n plus number 1. Taking number 1 to the left, I get 5 minus 1, which is 4, which is equals 2 to the 2 squared, which equals 2 to the n. Now I found the exponent n equals 2. Okay, finally I will have the solution x equals 4 correspond with n equals 2. Okay, now here is a one, here is one pair of the solution here. That's what I found here. Okay, this is only the solution that we found. So I have ended this video. If you have any question regarding this problem, or if you have any suggestions, just put it in the comment section below. So by the way, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.